My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 501. Let's understand some simple terminology about graphs. Some simple terms so that it is easier for us to follow through the rest of the case study. So, graph is represented as an ordered pair. What is that ordered pair? First one is V. V means what? It is a set. Set of vertices. What type of vertices? Non-empty set of vertices. E means set of edges. Just try to understand. There is a restriction on V. V must be a non-empty set. Whereas E set of edges means what? E can be an empty set or E can be a non-empty set. Anyway, we will try to understand the definition of graph after a few minutes. Time being, just let me proceed. Let me proceed further. So the graph is represented as a set of vertices and edges. Let's assume each of these, just let me say, represented as users. U1 means user 1, U2 means user 2, user 3, user 4. We typically represent users, especially in the social networking context. We typically represent each user as a vertex or a node. Let's say U1 is a friend of U2. So you are connecting these dots U1 and U2. How you are connecting? We are connecting these dots U1 and U2 with a line. Such a line is called edge or a link. So you can think of edges or links to be representing either friendship or the following. Especially when you are in Twitter or Instagram, where one person follows other person. Similarly, let's say U1 is friend of U4, isn't it? Let's say U2 is friend of U4. U2 is friend of U4. Let's say U3 is a friend of U4, isn't it? So this is how we represent a graph. Here it's a graph, isn't it? What is my V? Here V means set of all vertices U1, U2, U3, U4, isn't it? What is my E? E means set of edges U1, U2, 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 U4 is an edge, U4, U3 is an edge, isn't it? U1, U4 is an edge, isn't it? Yes, this is set of edges. E is set of edges, E is set of vertices, and V must be, it is a non-empty set of vertices, isn't it? It's a graph, yes? Yes. So graph in a nutshell is a set of vertices and set of edges. So the graph mathematically represented as an ordered pair V comma E. Each edge is a pair of two vertices Ui and Uj. Isn't it? Edge is basically a pair of vertices because it is connecting vertices. Graph basically consists of vertices and edges. Now, if you look at this graph, if you look at this graph, if you look at this relationship, it is a friendship relationship. If U1 is friend of U2, then U2 is also friend of U1. There is no direction. That is important. There is no direction from U1 to U2 and U2 to U1. Let me give other example. Let's assume I have users user 1, user 2, user 3 and user 4. This is actually, if you consider first one, this is what happens typically. Yes, this is what happens typically in I can say in the typically in Facebook and LinkedIn. There is another possibility. Let's assume on Instagram or Twitter. This is related to, just try to understand. This is one possibility. Here it's related to Facebook, and here let's assume on Instagram or Twitter. This is related to Instagram, or I can say the second one. This is first one is related to Facebook, I can say, or LinkedIn. Here this case is related to Instagram or Twitter. This is my second case. Anyway, we'll try to understand. Let's assume on Instagram or Twitter, U1 follows U2. This U1 follows. Here I have direction, isn't it? U1 is following. Here you don't have no direction here. It is undirected graph, isn't it? That is example Facebook. Facebook is an example for undirected graph, isn't it? Yes. Let's assume U1 is following U2. We represent that with an edge. You are representing that with the help of edge, isn't it? With an edge, with a link, with an arrow symbol, isn't it? This arrow symbol represent the fact that U1 is following U2, not the other way around. U3 is following U2. Just see, U3 is following U2, U4 is following U2, U4 is following U2, U3 is following U4. Just see, U3 is following U4. These are called directed edges, isn't it? All these edges are directed edges because there is a U4, a direct direction to the edge. From U4 you have direction to the what is U2. All these are directed edges. For example, in case 1, for example, this case, you don't have any directions. Yes, in this case, you don't have any undirected edges, isn't it? Here, what is this? This case is related to undirected edges, isn't it? This one is directed graph. This is undirected graph. Isn't it? The first case is called undirected edges. These are called, in the second case I have directed graph means directed edges because direction is associated with this. This is typically used in Instagram and Twitter. That is important. This type of things are used in Instagram and Twitter, where one person follows the other person. It is also possible that U2 is again following U1, isn't it? So there could be two edges in between two vertices, one in each direction. That's very important. And the data set that we have for the Facebook link prediction problem is directed graph. So by the way, the graph with directed edges is called directed graph, isn't it? This is directed graph. Why? Because it's a graph with directed edges. So for our problem of Facebook link prediction, the data set that are given is this. What is the data set? The data set is given this one. Which one? This is related to this, isn't it? Facebook link prediction, the data set given is this, where we have directed edges. That is important. The data given for us is the data which is related to directed edges. Facebook have not mentioned the data set is related to which social network. We believe, because Instagram is owned by Facebook, we believe that it is mostly from Instagram, isn't it? There is other important concept, path, which we need to explain. Let's learn what is a path means. Yes, so imagine if I have a graph like this. As far as this case study is concerned, we will only use directed graphs. So path here, path is a path in a graph is a sequence of edges. Yes, let's take an example. Imagine you are at the vertex corresponding to U4. Imagine you are at the vertex corresponding to U4. Now if you want to go to U3, isn't it? Think of this is a road network. That's easy way to imagine. So you can go from U4 to U2. So the path from U4 to U3, you can go from U4 to U2 and U2 to U3. So you have sequence of edges. The first edge is between U4 and U2. The second edge is between U2 and U3. Such a sequence of valid edges that are present in the graph. See, there is no edge between U4 and U3. There is no edge between U4 and U3. You can't use it. So you have to only adjust that the directed edges, isn't it? In this case, edges in this case means directed edges that are represents the graph. So if you are going from U4 to U2, if you are going from U4 to U2, U2 to U3, that is a valid path, and this path is said to have of length. What is the path length? Path length is of 2, because you have 2 edges on this path. Similarly, I could have taken other path. I could have gone from U4 to U1. I could have gone from U4 to U1 and U1 to U2, U2 to U3. That's also a valid path. This is a path of length. What is the length of this path? This is a path of length 3. So path basically means, in a nutshell, is a sequence of valid edges to go from one vertex to other vertex. Very simple terminology, nothing like fancy here. So let me give you a little intuition on the data set. We have the data set we have given is the Facebook challenge data set. You are basically given directed graph, isn't it? Directed graph which represent users in the social network. We think that it is from Instagram, because Instagram has this following type of structure, which means you have U1 which is following U2. It could also be following U3. U2 can also follow U4. Again, U2 could follow U2 could following back. In Twitter, you have lots of celebrities. Are followed by many people. Even in Insta, celebrities followed by many people. So there are all sort of possibilities. So given this basic introduction about terminologies and graphs, we will start progressing to this case study. I will continue this case study in my next lecture, that is in lecture number 502. I will discuss about data format and limitations. Thank you very much.